So today we'll start with databases. So basically we want to finish database designing. Okay. So that's our target mainly. So then we'll move on to web development. And if you have time, we'll move on to communication skills as well. Okay. Right. So database designing. The note is available in Google Classroom. So you can get the UCSC note as well. Uh, so let me open because last time we finished discussing relational data model. Okay. Including modeling inheritance using different concepts like overlapping versus disjoint, total versus partial. Now you must be very comfortable with those concepts. Okay. Right. Database design. So we are going to do this initially as a theory part, then we do it as a practical session. For this practical session, we will be using Microsoft Access, right? But when we move on to the SQL, we will migrate to MySQL. But because we want to do things quick and fast, and we just want to understand the designing concepts, so we use Microsoft Access as a sort of a prototyping tool. Okay, right. So remember, once you understand the requirements related to data, our next task is designing. Right? So designing involves designing the database, designing the user interfaces, designing the application business flows, designing the interfaces for integrations with other systems, and so on. And here we look at database or database or data designing. Okay. So our main objectives include minimizing the data redundancy or data duplication, enforce data integrity, okay? And also we need to think about other aspects like performance, security, right? As well. So good design will fulfill these objectives, right? Fulfill these objectives. And remember, we are only interested in relational database designing, structured data, right? We are not interested in semi-structured or unstructured data related designing. Okay. Right. So when it comes to designing, whether it's database or any design, we can subdivide it into two parts. Initial logical design and then the physical design. So logical design means more conceptual design without committing to a technology. Right? So we have committed to an approach, but not to a specific technology. So in databases, when we do logical designing of our database, so we don't commit to whether it's Oracle or MySQL or Microsoft SQL. We don't commit to that, but we have all decided maybe we are going to use relational database, right? So therefore, logical design is more logical level, conceptual level, that rather than committing to a particular technology. So then we refine the logical design to reflect the features availability of the available in the actual technology that we are going to use. Okay. So there are two advantages of doing like this two-step process. One is when you do the logical designing, so you don't need to worry too much about the technical aspects. So that relieves additional pressure so that you can only concentrate on logical level. Because when you are developing complicated things, so we want to separate concerns. At a time, look at only one thing. So that is how we handle complexity, engineers. So that is one advantage. So the second advantage is when you do a logical design independent of the technology, so then we can, after doing the logical design, we can pick and choose what is the best technology. Right? Is it MySQL, Oracle, right? So that means which technology has the best support for our design. Otherwise, what happens is you are biased towards the technology and try to design it according to the technology. Right? So therefore, this is the preferred way, logical design and then physical design. So this is not only for databases in almost all the aspects. So if you want to get the best design, first do the logical design and then go for the physical design. But of course, you must be aware of the physical aspects. Otherwise, you will come up with a logical design, which is impossible to convert to a physical design, right? But you must not too much committed into physical aspects at the early stages. Okay. Right. So remember, when we get into the logical database design, we have already decided, right, what kind of data we are going to work with. Is it structured, semi-structured, unstructured? And therefore, we have decided whether we go for, if it is structured, of course, we are only interested in structured data. So with a relational database, object-oriented database, we have decided. Or maybe relational database with some object-oriented support. Okay. So object-oriented database designing, we will discuss in your semester 3, because you have the data management system subject there. So here we only look at uh, the logical and the physical designing for relational databases. Okay. Right. So when it comes to the physical design, yes, we can decide whether we go for MySQL, Oracle, right, and so on. And so then we can think about additional concerns like file organizations, query performance, backup and recovery, security. So those aspects also now we can think. Addition to the this technology specific aspects. Okay. Some optimizations physically. Okay. So remember, physical doesn't mean something you can tangible thing, right? So physical means more closer to the reality. So a lot of students think that physical means something you can touch tangible things. So then someone can ask, so then why do you learn in physics, right? So physics is also related to physical, right? Yes, in physics we learn about matter, right? Mass, weight, but at the same time we learn about electricity, light. So light is not tangible, right? But it's physical. Physical means it's a reality. But logical means it's more conceptual. Okay. So reality is you need to ultimately develop this using Microsoft SQL, Oracle, Microsoft, MySQL, and so on. That is the reality. Physical means reality, ultimate reality. Right. So remember, we have already discussed how to analyze and model the data related requirements. And there we use certain terminology like entity, relationship, attribute, uh, identifier, and so on. So in designing also, we use some of those terms, but at the same time, we use some additional terms as well. For example, rather than entity, in designing, we mostly call it table or relation. Right? Rather than attribute, we mostly call it field. Your identifier will become a key or primary key, and so on. Okay, so therefore, yes, we will be using some words we use in analysis, and in some cases, we use some other technical terms in designing and development. Okay, right. So let's start with relations. So first, what we are going to do, we want to familiar with the terms, the design terminology, and additional concepts when it comes to designing. Okay, right. Relation. So relation is the same meaning, right? So in analysis, we call that entity. Entity means anything, any concept that we are interested in keeping the data, like customer, employee, student, order, payment. Remember, entity can be living physical, non-living physical, or conceptual. So the relations are also same thing, but in design terminology, we call it relation or table. Right? So now in the table, we can save records. Right? We can save or persist records of that entity or entity instances. Right? So this is how you look at a table. So your table or relation has fields, or you can call it still attribute or columns, right? And you have records or tuples for that table. Okay, records or tuples or tuples. So this is table or relation. This is field, attribute, or column. Okay. So then we'll look at few more concepts, right, as well. So what is meant by attribute domain of a field? So attribute domain of a field means a set of possible valid values for a given attribute. Right? It can be set of values or range of values, or it can be anything. For example, if you say month, so only possible values are January to December. Say marks, so anything between 0 to 100, if you give marks by 100. But if someone says salary or something, it can be almost anything, right? So that is called attribute domain of a field. Possible values or possible value range for a field or attribute. So these are just theory, okay? Nothing big serious, but you must aware of these things because in the exam they ask questions on these as well. So then someone will ask, why are we interested in these things? Because later you need to design or decide data types. Okay, so that is why we want to have some terminology for this. Right. So the next one is cardinality of the domain. Cardinality of the domain means number of values in the domain for that field. So if it is days of a week, 7, months, 12, marks, maybe 0 to 100, 101. So that is how many possible values are there. Okay, how many possible or total number of values for that particular domain. Domain means business area for that particular field. Next one is degree of relation. Anyway, that I think, no, we did not discuss about degree of relation. We discussed about degree of a relationship, like unary, binary, ternary. So similarly, now we can think of degree of a table or relation. So degree of a table or degree of relation is number of attributes in the relation. For example, this one has 4 attributes. So therefore, degree of this relation is 4. And over the time, maybe we will add another attribute. So then that degree become 5. So degree is not a constant. But in general, it's constant unless you do a structural change. Degree of a relation. Okay. So then we have cardinality of a relation. Cardinality of a relation or table means how many records are there. So this is something all the time it change, right? When the database is in operation, so this can be changed because when you insert a record, so cardinality increase. When you delete a record, cardinality is decrease. But when you update a record, it doesn't change. Okay. Cardinality of a relation. So remember we discussed about cardinality of a relationship, one to one, one to many, many to many. So this is cardinality of a relation. Right? Degree of a relation, number of fields. Cardinality of a relation, number of tuples. Cardinality of a relation change when the database is in operation. Degree of a relation change when you do some structural changes to your database. Right? Adding a field and so on. Right. So then the concept called null value. So in database terminology, if a particular field doesn't have a value, you don't say it is blank. Right? So rather we call it null value. We consider it as also as a value. And this null value can be given to any data type. Numeric field, we can say it's null. Varchar or string field, we can say null. Date field, we can say null. So therefore, in database terminology and also in SQL, if there's no value, we say it has null value. And we can check whether the value is null and so on. So it's NULL without quotes or whatever. Okay. But it doesn't mean that when you look at the database table, there's a value called null. No, nothing. You will see nothing when you look at the table for that particular field, for that particular record. But in queries and so on, we say it has null value. Okay. That's another concept. Right. So then the primary key and related concepts. The concept of primary key and some related concepts. So our main concern is yes, primary key, but you can see there are so many other related concepts. Super key, candidate key, alternate key, right? Then of course, categorization of primary key, simple versus composite, domain versus surrogated. So you must be familiar with these concepts. Okay. So remember, in analysis, we use the word identifier. So what is an identifier? Identifier uniquely identify a record in that entity, like student ID, payment number, order number. So in designing,
Sir,
yes, any question?
sir, does the primary key related to the database?
Yes, primary key is related to the database. Yes. So that is what we are going to. This is now we are talking about the primary key and related concepts. So primary key is one concept, but there are some related concepts when we select primary key. So there are some related concepts we use to identify what is the best primary key. Okay, right. So I hope you got the answer. Right. So what is mean by candidate key? So now we are into the design terminology. So candidate key means, remember, we always need a field or set of fields to uniquely identify a record. Why do we need that? Because practically we need that, right? For example, say you want to inquire about your payments. So then Somerset admin team will ask, what is your student ID? Right? So you want to inquire about your BIT results. So whether you have done your registration, payments done, received or not. So then they will ask, what is your student registration number? Okay. So you want to inquire about a particular transaction, suspicious transaction. So then they will ask, what is your account number? Right? Then only they can locate your record, locate you in the database. So that is called identifier. So there can be multiple such fields, multiple such fields. Right? So those possible fields that we can use to identify, uniquely identify a record is called candidate key. Right? Candidate key. Okay. So maybe there is employee ID, NIC number, maybe it is email address. Okay. So those are called candidate keys. So maybe you have multiple candidate keys, not just one. But we need to identify, yes, these are possible candidate keys. Okay. So then out of those candidate keys, okay, we'll come back to super keys later. We will pick one as our primary key. So that means, yes, we have more than one options, but we don't need more than one option. We just need one of those candidate keys to uniquely identify a record. So once you pick that, out of the candidate keys, maybe you have only one candidate key, multiple candidate keys. So once you pick that, we call it primary key. Right? Primary key. So here primary means main. So remember the word primary has two meanings. Right? The word primary has two meanings in English. One is basic. That is why we say primary school. The kids school is called primary school. That is the basic, elementary. So the second meaning for primary is the main. So here when we say primary key, it means the main key. That's main key. Okay. So we need to select the primary key out of the candidate keys. And we select only one primary key. We don't select more than one primary keys. So then how do you decide which one of the out of the candidate keys you are going to select as a primary key? Can you think of three good features of a primary key? Maybe you have learned these things, or maybe you can use your common sense now. So now we have some possibilities, right? How do you decide? So just use your common sense. Anyone?
Not null.
Yes, that is superb answer. So it must be a not null field. So if there's a possibility of some records, it's a null value, that is not a good option. Maybe a candidate key, but maybe that is a negative point to when it comes to selecting the primary key. Right? What else?
Or any duplicates.
Yes, no duplicate values.
Does not have any duplicates.
Yeah, so no duplicate values. That is another feature we want to check. If there are possibility of duplicate values like salary, right, or department ID for employee, so that is not a can actually then it is not a candidate key also, right? Not no null values possible, no duplicate values. Anything else? Anything else? So basically, those are the two
Should be
properties.
uniquely identified.
Yes, obviously uniquely identified. Actually, I forget about that. So that is number one actually, right? So that is the number one actually. So I completely forget about that. Uniquely identified, no duplicate. Actually, no duplicate value means again uniquely identified anyway, and no null values. Okay. So the third one is it's sort of a debate, not debatable. It's sort of a flexible concept. That is, if you have full control of the primary key, that is better. That means we don't rely on the users or the customers to provide the primary key. So then it is better. That means in general, if we can control the primary key, that is better. And also this primary key value must not be changed once you entered it. Right? Once you enter it. That is another important property. So usually we don't change primary keys. And we need the control of the primary key. Ideally, we must be able to generate that value. So anyway, we call that surrogated primary key. But anyway, it's not a must, but a good practice. So likewise, so now we need to select out of the candidate keys, what is the primary key? Or we can generate our own primary key and say, this is our primary key. Sometimes that also happen. So we generate a unique key and say, this is the primary key. Okay. So once you select your primary key out of the candidate keys, now the non-selected keys are called alternate keys. Say we selected student ID as a primary key, but there was a candidate key called NIC. Now NIC is an alternate key. And student ID is your primary key. Okay, alternate key. So there can be multiple alternate keys. Once you select your primary key only, we can talk about alternate keys. So this is an example. Okay, so maybe this is not in your note because I added this recently. I will upload your PDF, new PDF after the class. Okay, with this slide, actually only this slide. Okay. So this is the selected key to uniquely identify record. So therefore, say it is our decision. So that is our primary key. Maybe these are originally candidate keys because pretty much NIC is unique, email is unique. But there are issues like maybe someone will say, I don't have NIC, I can't remember NIC. So then maybe preferably we can generate the employee ID also. But that is not a must. So once you pick primary key, the other candidate keys become alternate keys. Right? Alternate key. So these are not even candidate keys for primary key. Okay. Yeah, preferably auto number or something like that. Yeah, machine generated number. Machine generated number. It is not always auto number, but mostly we go for auto number most of the time. Sometimes we can even use something like timestamp and so on as well. But usually better to have like auto number, auto increment number 1, 2, 3, 4, 5, 6, and so on. Because there are some additional advantage. Okay, right. So alternate key. Right. So then what is mean by super key? So super key means primary key plus anything else. Primary key plus anything else. So that is super key means superset of primary key. So maybe your primary key is employee ID. Then employee ID plus name combination is a super key because this is also uniquely identified, but this is not the minimal. Maybe employee ID NIC number. Super key. say NIC number is your primary key, assume. So then NIC number name is a super key, but it depends on which. Now here I assume this is the primary key. Okay. So your super key must include the primary key. Right? Super key must include the primary key, but it must include something else also. Something else also. So then only we call it super key. Anyway, that is more for our some theoretical discussions later on, like functional dependencies and so on. Okay. So there we will use this word super key. Okay. So super key is not the minimal. Super key is not the minimal. So dependencies we will take separate. It's a separate topic for partial dependencies and so on. So we will discuss those there. So we are not touching those concepts in this discussion because we have a separate topic for that. Okay. So there we will look at those partial dependencies and so on. So simple definition is just you need to understand is super key is anything your primary key plus something else. Of course, if it is only your primary key, that is not a super key, that is your primary. Okay. Right. So then your primary key can be either simple primary key or composite primary key. Simple primary key means it's a single field primary key. Like student ID, order number. Okay. One field, single field is selected as your primary key. Composite primary key means you select multiple fields, combination of multiple fields as your primary key. So there are situations we need to select composite keys, especially when we create connecting tables for many-to-many relationships. So then the connecting tables primary key is usually a composite primary key, unless you go for auto number, surrogated key. Okay. Single field is simple primary key. Composite primary key is, so your primary key consists of multiple fields. So there are situations only that this combination is unique. Otherwise, duplicates are there in a particular table. Right. So the final classification is domain key versus surrogated key. So domain primary key means it has some business meaning. Your selected primary key has a meaning other than you uniquely identify a record. That means in the business or any other domain, it has certain meaning. Right. For example, if you select national ID, NIC as your employees table's primary key, now you know that NIC has other meanings. So they use NIC for different places. Right? Even police will ask for NIC for their identity, but this is our customer. So then it is a domain key. And also, if it is used in our business also, we use that, we ask them to write that. So then still it's a domain key. Say, for example, if there's an issue with your domain, your order, if customer should give you the order ID, that is a domain key. So surrogated key means usually machine generated number. And most of the time, surrogated key is not visible to the customer or client or even outside the system, it is not visible. It's only visible inside the tables. And we use internally to uniquely identify a record, joining records as when we are using it as a foreign key. Right? Externally, we are not interested in what are the values. So then we call it surrogated primary key. So in modern database designing, we often go for surrogated primary key. Okay, because then it is not going to be changed, right? There's nothing called the value is not there because it is anyway, we always generate it. But again, it's not a must. Of course, we can go for domain key. But usually we prefer to go for surrogated keys in serious database design. Because we get rid of a lot of practical issues when we go for surrogated keys. It doesn't mean that Still the order ID will be there, that customer referring to, but maybe internally we don't use order ID also. Maybe some other unique number. Or maybe that order ID surrogated key we use in domain also. So therefore, there's a bit of gray area. Gray area. Sometimes surrogated key is not visible to the outside. Sometimes surrogated key or maybe surrogated key plus something else can be used as domain as key as well. But the idea is as much as possible, don't go for keys taken from your customer. Then you rely on the customers to get the unique value. Sometimes customers can make mistakes. Then you need to change it. Okay, so if you use NIC as the primary key, if customer says later on, I have given you the wrong value for my NIC, then we need to change the primary key. But ideally, we should not change primary keys, records the primary key values. So that is why we try to generate from our system and go for surrogated primary keys. Okay. Right. So we all discussed the features of good primary key. Uniquely identify a record, must not change from time to time. Right? And you must not rely on the customers to give you that value. That is where the surrogated keys are preferred. Okay, right. So any questions? Right. So the next concept is how do you design and of course later develop derived attributes. So remember derived attribute means we can derive it from another attribute, right? So age can be derived from date of birth. So therefore, when you design, make sure you don't consider this as attribute for your table. Why? Once you get the date of birth from the current date, system date, we can calculate this. Otherwise, we waste our resources, right? So that is one reason. So one reason is it's wasting our storage. What is the second reason? Not to keep age in our database table. Anyone? Second reason. I gave you one reason. It's waste of storage. Yes, waste of storage is redundancy. So what is the second reason? So waste of storage is because of the redundancy. What is the second reason? Better not to keep age. Rather keep the date of birth in your database. So just common sense. No one? So age is keep changing. So in 2025, if you save it as 20 years, then 2026 maybe it has now his age may have become 20, not may have, definitely 26. So then that age is wrong. Maybe that age is correct at that time, insert time, but now it is not correct. So therefore, keeping age is asking for troubles. So therefore, anyway, it's best thing is keep the date of birth and then derive it. Okay, derive it. Right. So therefore, what is the design idea? Don't allocate field for the derived attributes, only for the main attributes, because derived attribute values we can calculate. Right. So what about when you have composite attributes? So when you have composite attributes, that means that attribute we can further divide meaningfully. So then in your table, make sure you have those sub attributes only. Sub attributes only. Not address field. Number, street, city. Okay. So what is that? What are the advantages? Anyone? Why this is preferred as a design? So you must know the reason also, right? Not just memorizing blindly. what is the main advantage of keeping these three fields rather than keeping a field called address? Still, I didn't get the answer. So what is the advantage of keeping this as three fields rather than one field called address? So the main advantage is, especially when you are doing researching, right? Because remember the data science is there, marketing and so many other concepts are behind databases. So when you are searching for, say we want to search customers from a particular city, so then we have one field to search. Otherwise, we need to extract the address and we never know where is the street, maybe comma separated, different address formats. But now we standardize our address, number, city, street, city, and so on. So then it's more searchable, easy to retrieve, more efficient to retrieve. Right? It's more data analysis friendly. Okay, so that is why we go for something like that. But again, it depends. If you are not interested in that kind of analysis and so on, still you can go for address as one field. It depends on your future usages and so on. But in general, we go for sub attributes. Right. So then what happens if you have multi-valued attribute? So multi-valued means there's a possibility of more than one value. Say someone will say, what are your language capabilities, proficiencies? So then someone will say, I speak English, Tamil, and Sinhala. I speak English, Sinhala, and Korean. So that means multi-values are possible. But in database tables, we don't keep multi-values in a field, comma separated or whatever. So that actually you later you will learn there's a normalization concepts. It actually violates the first normal form. That means it is not even in the first normal form, one in it. So therefore, in case there's a possibility of multiple values like skills, contact numbers, we need to introduce a new table and map it as one-to-many relationship. This is employee contacts. Then employee can have multiple contact as records rather than comma separated values. So if you have multi-valued attributes, go for a new table and relate it to the main table using one-to-many relationship. Okay. Okay. So that is how you do it. Right. Now let's see how to model relationships. Now remember when you design relations or tables, you need to identify the relations, then identify the fields, identify your primary key, and for fields, identify the data types. Okay. And think about those multi-values, composite attributes, derived attributes when you decide your table structure. Right. So then the relationships. So what is a relationship? Anyway, because we discussed under analysis. And what is mean by relationship in database? Why do we have relationships? What is a relationship? And third one, how to create a relationship. What is a relationship? What is a relationship?
Associations between entities.
Yes, association between entities. Connections between entities. Right? Connections, associations are called relationships. Why are we worried about or why are we concerned about relationships? Anyone? So what, why, how? Why are we interested in relationships? Why are we interested in relationships in databases, in database design? So simple answer is in reality, in business, these entities are related. So this order is by this customer. This payment is for this particular order. Okay. So this student is following this particular course. So then in real world business domain, if there are connections, so we need to preserve those connections in the database also, so that we can identify. So that is why we are interested in relating tables. Right. So the final question is, now you know what, why, how. How do we create relationships? Simple answer. Anyone who has done a little bit of database? Anyway, we discussed this in semester one also. How do you create relationships? You can just give me one.
Using foreign keys.
Yes, using foreign keys. Simple as that. Simple answer is, how do you create relationships using foreign keys? So now we have another type of key, foreign key. So then you must have answer, what is mean by foreign key? Yes, we know that according to your answer, we use foreign keys to create relationship. We know the purpose. Why? So then what is a foreign key? Then we need to understand how to build a foreign key in our particular database technology like Access or MySQL or whatever. Right. So of course I have not explained you what is a foreign key, but you guys should have learned these things in your schools as well, right? O-level ICT, A-level ICT. Most of you guys may have done it, some other IT courses. What is a foreign key? Try to give me the words.
Foreign key of another table.
Sorry?
Primary key of another table.
Primary key of another table. Okay. So then what is the relationship with this table? So you are talking about other tables. Are you referring to this table also?
Itself references in one table to a primary key in another.
Yeah, so I think that is a little bit complete answer rather than just say primary key of another table. That is part of the answer. So foreign key is a field in a table which is mapped to the primary key of another table. So field in a table which is mapped to the primary key of another table is called foreign key. So why do you introduce that mapping or introduce that foreign key? Because it creates the relationship. It creates the relationship. Okay. Because we need to preserve the relationships so that we can navigate from one entity to the other related entities. For example, from the customer, we want to find out what are the orders. Maybe from orders, what are the payments? Okay. So that is what relationships are. Relationship is, and relationships are based using foreign keys. So this is called referencing relation. This is called the reference relation. Employee is the referencing, department is a reference. Because in the exam, they have even asked this. They have asked, given a relationship, which one is the referencing, which one is the reference. Okay. So most of the time in some books, we underline the primary key. Foreign keys, we mark like this. Because then you can differentiate the primary key and foreign key. But some books, they just say it's a foreign key, or sometimes they make it italics. So you can use whatever the convention you like. Okay. A field in a table which is mapped to the primary key of the other table. So always foreign key must be mapped to a primary key of the related table. So that is one of the important concept in relational databases. In network databases, early days, we used to take any field and map it to here. So then it is not a relational database. In relational databases, only foreign key is mapped to a primary key, not to any other field. Okay. So that is a very, very important feature of relational databases. You never ever map your foreign key to any other field other than the primary key of that table. Right. So when it comes to relationships, remember we look at degree of a relation, cardinality of a relation, number of fields is called degree, number of tuples is called cardinality. So similarly, we have the degree of a relationship and cardinality or multiplicity of a relationship. Anyway, we discuss this under analysis also. So degree of relationship means how many entities involved in that relationship. So it can be binary most of the time, but at the same time, it can be unary, ternary, or more than 3, that is n-ary. Okay. And multiplicity can be 1 to 1, 1 to many, or many to many. Okay. So why do we think that? So there's a question. In entities, we are interested only in attributes. So payments are behaviors. So your question is, this is what you see, right? Customers, you will accept that, yes, customer is an entity. Okay. So then customers go and do a payment. So your question is based on that. So therefore payment is a behavior. So therefore why are we interested in these behaviors? So that is your question, right? That is your question. So what is entity? So your question is, we only take. By the way, now why do you think that behaviors are not entities? What make you think like that? You think that only data must be in database? Is that your argument? Because we have.
Because in entities, we are interested only in attributes, right? If we are interested on behaviors, it will be objects. Isn't it?
Okay, so what do you map in tables? What kind of things going into the tables? Now you have three words, right? Entity.
Attributes,
No, just wait. Entity, attribute, behaviors. Right? Entity, attributes, behaviors. What kind of things we map into tables? I give me the straight answer. Is it entity, data, or behavior?
I didn't get it.
Now, when you going from analysis to the designing, we need to map certain things as tables, right? So my question is, which things do we map as tables? Is it entities are mapped as tables?
Behavior.
Attributes are mapped. So just wait until I finish my question. Is it entities you map as tables, attributes you map as tables, or behaviors you map as tables in database designing?
Entities.
Entities. So your question is, we map only data, not behaviors. No, we don't map data. We map entities. So payment is entity. Payment itself has attributes: payment ID, payment amount, payment date. Okay. So therefore, we map entities, not data. Right? So therefore, we don't map only attributes because attributes are the data of that entity. So therefore, payment is an entity. So entity is a major concept that we are interested in identifying, later retrieving. So payment is a major concept. Order is a concept. Right? Cause is a concept. So then do you think that cause is a behavior? No, cause is a. So that is why we subdivided entities into living physical entities, non-living physical entities, and conceptual entities. So order is a conceptual entity. So out of the entities, we only map data. Data of the entities. So therefore, order is an entity, payment is an entity, post is an entity, vehicle is an entity. Okay, so that is why we map order into table, because we need to keep details about order date, order amount, order type. right? So it's very important to understand what is an entity, what is a data, what is a behavior. So therefore, entities are major concepts, not we map major concepts into tables because we are interested in saving those details, retrieving those details. Okay. Right. So that is the answer for that. Okay.
Got it, sir.
Okay. Right. Right. So then when it comes to entities or relationships, so it can be one-to-one, one-to-many, and many-to-many. Okay. So card degree must be unary, binary, ternary, and so on. Cardinality can be one-to-one, one-to-many, many-to-many. Right. So what is mean by one-to-many relationship? One instance on A is related to many instance of B, and one instance of B is related to one instance of A. So that is called one-to-many relationship. So then how do we model or design one-to-many relationship? Now we are into the design. So you add foreign key to the many table. So one employee work for one department. One department can have many employees. So therefore many side is employee. So therefore foreign key goes to the many side. And the foreign key must be mapped to the primary key of the primary key of the one side. So the primary key of the one side say department ID. So then you add department ID. You can use other name also, but then map it to the department ID. So I usually use the same name also. Then you can easily see it. So always in one-to-many relationship, foreign key is in the many side, not in the one side. Okay. So then every employee you can have a single one particular department ID. And same department ID can be for multiple employees. So that is why we say department can have many employees. So you can see department 2 has Bob and Tom. But one particular employee can have only one department. Okay, right. So now we are going to gradually build this, right? So let's go to access because I hope you guys have access with you. Any version, I don't care. Any version of Microsoft Access. If you have Office, you have access. Just create a blank database. So let's create a table. Let's call it employee. Employee. Go to the design view, right click and go to design view and add some fields. I'll call it employee ID. Okay. Or you can just call it ID also because it's in the employee table, but I just give it employee ID and I'll go for tour number. So remember in access, name is a keyword. So therefore you can't use name as a attribute or field name, unfortunately. So therefore I'll just call it ename because name is this keyword in access. But in MySQL and everywhere, I will just call it name, okay? The ename, employee name. So you can pick suitable data type. I will use maybe simple text, maybe salary. I'll go for, you can do it parallelly. Maybe number, or even you can go for currency. I'll go for number. And I don't need a lot of fields. Okay? Employee ID, name, salary. But later I will add foreign key as well. But for the time being, let's say that's all I need. I'll save it. Okay. So now again, when you go to design view, basically are looking at the data dictionary, metadata. What are the fields? Now by default, employee ID, they have picked it as primary key. You can see there's a small key symbol. If you want to change it, you can select another field and right click and say primary key. But I will keep employee ID as a primary key. Okay. And it is surrogated primary key I have, auto number. So let's create another table. Create table. Save so that you give a name. I will call it department. So just follow a convention. when you're naming. Whatever convention you familiar. So for me, when I work with databases, I always go for all simple. If it is more than one word, I separate by underscore. So maybe you can always use capital, right? Department name, uh, say employee number, maybe E capital, N capital. But I will use all simple separated by underscore. But whatever the convention, you consistently use that. Okay, right. I'll call this department. Department table. So I go for design view and say department ID. Auto number primary key. Again, name is a reserved keyword, so therefore I call it D name. Maybe location or something. Or you can go for something like budget and so on. Right. So now I have two tables. Right. So now I want to create a relationship between department and employee, one to many. Employee work for one department at a time. Department can have multiple employees at a time. So that means one to many. The many side is employee. Department can have many employees. So therefore, foreign key must be added to the many side. So therefore, again, open the employee table in design view. I will add, you can give any name, but I like to keep things simple. I will use the same name as primary key of the department table. Department ID. And it must be number because there it's auto number. You can't go auto number here because this is not your primary key. So therefore, use a compatible data type, like number line. Now I have the field, but still it is not the foreign key. Unless you map to the primary key, just because the name is department ID, Access will not consider it as foreign key. So now you need to map it. In SQL, there's a way to map it that we will discuss when we do SQL. But here, there's something called database tools. Tab, go to relationships. And you can see the two tables. Add both the tables, but don't add two times. Just add once. By mistake, if you add two times, just close it without saving. Right? I'll select the both and say add selected tables. Right, so now I have the department table, employee table. Okay, I'll take employee table to this side. Now this is my foreign key, but still it is not the foreign key. That is what I am going to make it foreign key. So it become foreign key when I map this to the primary key of the department table. Still I have not mapped it. So in Access, how to do that? Just click on your foreign key field that you want to make it foreign key and click it. Don't release the click, then drag it and on top of the primary key, just release the key, click. Okay, your mouse. So then there's a dialog box. It shows department tables, department ID, and employee tables, department ID. And make sure you tick enforce referential integrity. And already you can see it's one to many. Okay. One to many. So if you want, you can tick the other two, but let's not forget, worry about those things right now. One to many. It has already identified that it's one to many. Then you make sure you enforce referential integrity. I will explain that later and say create. Right. So in Access start than n, it use infinity symbol to denote many. So anyway, that is Access way of doing things. So you can always think infinity as n. So therefore, its department can have many employees. One employee can have only one department. This is how you do one to many. This is not only design, we even implemented it.
So does this relation?
Sorry?
Does this the relation between
What do you
two
mean by
tables?
this? Is it this line?
Yeah.
This line is not the relation. Relations are employee is a relation, department is a relation. This is the relationship. So remember when it comes
Okay,
to
sir.
entities, in ER modeling, we call it entity. But in designing, we call it either relation or table. relation no table. Naya, nakama. Main nayo denna, mina nakama. Relationship is nakama. Okay. So therefore, this is the relationship. This is analysis terminology entity, design terminology relation, development terminology table. Okay. But this is always relationship in any terminology, relationship. Okay. Right. So that is how you create one-to-many relationship. Binary one-to-many relationship. So now we can add some data also. Make sure you save it. Say let's add some departments. So department ID is auto number. I'll say HR, maybe FIN, maybe MKT market. Right. I have 3 departments. Then I will add few employees. Say Nimal. Salary is 100,000. Say department is say 2. Say Kamal. Say 120,000. So department is 1. Say Raju. Say 150,000. And say department is empty. Let's see what happens. Okay. Say Rehana 130,000. Say department is 2 again. And let's see whether we can save it. Right, we can save it. So that means this is null. It doesn't show you as null, but actually it is null. Okay. If I open it again, so this is access, it doesn't show you as null, but in most of the other databases, you can even see the word null. But here you can assume it is null. Okay. Right. So therefore, Nimal is working for department 2, Kamal is working for department 1, Raju is not working for any department, and Rehana is working for department 2. Okay. So when you're adding a department ID, remember I asked you to tick enforce referential integrity. So I will explain what is enforced referential integrity also. So that means when you add a department ID in the employee record, it must be a valid value in the related table, or it must be null or empty. Right? For example, valid values for department table is 1, 2, 3. So you can have 1, 2, 3 or null or empty, but nothing else. Now you can see it has already accept the no value also. But you can't have something like 5. If I save it, you will get error. You will get error because it violates referential integrity. Okay. So therefore, either you keep it blank or at a valid value. Now I can save it. Right. Any question about how to create one-to-many relationships? Any question? Even if you have even a slightest doubt or anything you want to get a little bit more details, you can ask, because we are not going to look at how to map, how to design one-to-many relationship in the future in your BIT. This is the time. Because in other
So
semesters,
how
yes,
do you set the primary key?
primary key. So when you create the table, you set the primary key. For example, if you go to the employee table, design view, so you select the field and right click and say primary key. That is how you set the
Okay.
primary key. Okay. So by default, your first field is taken as primary key. But if you want to change it only, you need to go and do that. Right? Select that field, or if it is multiple fields, select multiple fields using control and say primary key. Okay. Right. So that is how you design and develop one-to-many relationships. Okay. One-to-many relationships. Right. So now we'll move on to one-to-one relationship. Right? One-to-one relationship. So this is binary one-to-many, right? Right. Binary one-to-one relationship. Anyway, forget about the binary. One-to-one means one instance of first entity is related to a one instance of the other entity and vice versa. Okay, vice versa. That means one instance of A is related with one instance of B, and one instance of B is related with one instance of A. So that is called one-to-one relationship. Right? And we know that in reality there are one-to-one relationships, husband and wife, okay. Country and president. Very rare, but possible. So if there possibility is there, we need to facilitate them. Right. How do you create binary one-to-one relationship? Because unary we will take separately. Right? Initially, we are only concentrating on binary between two, because binary is the one that is easiest to understand, and most of the time, more than 90% of the time, what you get is binary relationships. Right. How do you create one-to-one binary relationship? There are two ways. One way is, for the most widely used approach is, again, you create a foreign key, but make sure your foreign key field is unique field, not a primary key, unique field. That means you can't have duplicate values for that foreign key field also. So then it create a binary one-to-one relationship. Okay. Say this is my employee and I have spouse. So spouse is husband or wife. Say every employee is related to one spouse and one spouse is related to one employee. Therefore, it is one-to-one relationship. So what is the easiest or the best way to create this one-to-one relationship? Add a foreign key to one of the table and make that field, foreign key field, also unique. Usually foreign key fields are not unique, but you make this foreign key unique also. That means you can't have duplicate. Remember the earlier we created department ID in the employee table, but we did not make it unique. So that is why for different employees, we can have the same department. So that effectively facilitated one-to-many. But the moment you make this field also unique, now it is one-to-one. Because no two spouse can have the same employee. No two spouse can have the same employee. So that effectively make it one-to-one. And of course, one spouse cannot have more than one employee ID because fields must be atomic. Comma separated and blah, blah, blah is not allowed. Okay. So then it make it one-to-one. Okay. Right. So any questions? So let's create that also. First, I will create the spouse table. Right. So then the question you should ask is, to which table we need to add the foreign key? Because now it is one-to-one. Earlier I told you add it to the many side. But now can I say add it to the one side? No, because both are one. So then how do you decide whether we are going to add it to the spouse table or employee table? So there's a rule. If anyone has gone through the notes, or if anyone has learned these things maybe in a different course, can you give me the answer? So I ask you to go through the notes before coming to the class. Then only you can ask questions more freely. Because you come to the class with set of questions. So you are in the class to resolve these questions. Okay. Can anyone tell me to which table do we add the foreign key? Or is it randomly? කාසියක් උඩ දාලා තීරණය කරනවාද මේකටද මේකටද කියලා? If anyone has read the note before the class, you should have answer. Right. No one. Right. So if the relationship is between a strong entity and weak entity, and of course in this case, spouse is a weak entity. Spouse is not the major concept, but we need. So therefore, spouse is a weak entity. If your one-to-one relationship is between strong entity and weak entity, add the foreign key to the weak entity. Okay? Weak entity. That is a rule. But if it is between two strong entities, so you can add it to whatever the entity you want. Okay? But again, with the experience, you can decide whether should I take it to the first entity or the second entity. Okay? So that is how you decide. That is how you decide to which entity you add the foreign key. If it is between strong entity and weak entity, you add it to the weak entity. Okay, got it?
Yes, sir.
Right. So if you are a critical thinker, now you must ask a question. What is that question? If you are a critical thinker, I told you that if it is between strong entity and weak entity, add it to the weak entity, not to the strong entity. Now, if you are a critical thinker, you must ask a question. Of course, if you are not a critical thinker, you will not ask any question. What is the question you must ask? At least by yourself. And if you can't find the answer from yourself, you must ask it from me because I am the one who told that add foreign key to the weak entity, weak side.
Why do we add to the foreign key of
So that is a
weak
question you
entity?
must ask, right? Why? Because I just gave you a sort of a command, right? Suggestions without giving any reason. Without giving any reason. So I will ask that question from you now. Why do we add foreign key to the weak side rather than strong side? Any idea? Any guessing? What is the idea behind? Or why do we say as a best practice or as a design concept, add the foreign key to the weak side, not to the strong side? Just maybe if you use your common sense, sometimes you can guess it. Of course, if you have learned this, you must have asked that from that particular moment, right? Why? If you are a critical thinker. Because if you don't know why, right? So you are not very confident, right? You're not very confident about what you are doing. But when you know why and you are doing, so then you are very solid, right? So the reason is, so this is our main concept. So remember, we first insert employee details because we are interested in employee. So definitely we will not start entering spouse details, right? When you enter data, we will enter first employee details. So then only we will enter the spouse details or the spouse of the employee. So by the time you enter this record, already employee record is added and you have the valid employee ID. So that we can edit. That we can edit. Because already employee record is there and you know the employee ID. Now you can add that for it. But if you do it in the other way, if you add the spouse ID here, right? So by the time you enter the employee, the spouse is not added because usually we start with the employee, not with spouse. So that is why we add the foreign key to the weak table. But again, if both are strong, of course, we never know, right, which record will be added first. So therefore, maybe one of those. But again, if you feel like the first we add this and then this, so then add the foreign key to the secondary table. Secondary table, because by the time you have the value, otherwise you need to insert and later update once you have the foreign key. Right. So that is the reason. That is the reason. Okay.
So what do you mean by entity here?
Sorry.
What do you mean by exactly entity here?
Entity is anything that we are interested.
Okay, sir.
Anything that we are interested. So I'm interested in employees, I'm interested in departments, I'm interested in the projects, I'm interested in students, I'm interested in courses, I'm interested in their payments, right? If it is supermarket or something, I'm interested in order, products. So anything that we are interested in is called entity. Okay. So this is a confusion, right? So that is why, remember when we discussed in the very first day in BIT semester 1, very first day. So the first lecture, right? Semester 1, Introduction to ICT. This is the very first lecture we did in semester 1, Introduction to ICT. So we discussed what is data, what is entity, and you can see there's a red notice, never confuse data with entity. Because this is sometimes even after one semester, 1 year, students still have this. I told you, think about this seriously. What is entity? What is data? Data is not entity. Okay. So now we have had more concepts like relationships also. Okay. Relationships also. So never confuse data with entity. So that is one of the biggest confusion students have. So that is why the very first day I emphasize, think of this seriously. Okay. Right. Right. So that is one approach. Add the foreign key and map it. But make sure your foreign key is unique. Right. Now let's create this. So let's add another table called spouse. Right. Another table called spouse. Say spouse. And let's add some fields. Say spouse ID. Auto number. I'll call S name because name is a reserved word, keyword. And maybe just that's enough. Spouse ID and spouse name. Okay. Now I have a weak entity. Okay. So now what I'm going to do? Add the foreign key to the weak entity. Because I'm going to create a one-to-one relationship between spouse and employee. So therefore, I will go to the design view and I will add employee ID. I will go for number because it's a primary key auto number. But before mapping this to the primary key, I will make it unique field. Otherwise, it will be a one-to-many. I will select this field and in the properties, there's something called index, access. It says yes, duplicate, okay. That means duplicate values are allowed. There's a drop down here. I will say yes, index it, but no duplicate. So no duplicate means it's a unique field. Now I have made it no duplicate or unique field. And now I will close this, save it. Now I'll go to the database tools, relationships. Right click and say show tables. And I will take the spouse also to the stage, spouse. I'll take it left hand side of employee because relationship is between spouse and employee. Now I have the foreign key and it is not the foreign key, the possible foreign key in the future when I drag and drop. But I have already made this unique, no duplicate. Now I can drag this and put it into the primary key of the employee table and drag it, release it. Now you can see it has already identified it as one-to-one because I have made it unique. Because I have made it unique, it has identified one-to-one. Earlier, it was identified as one-to-many when I did the same for the employee and department. And again, enforce referential integrity and create. Now what it says? Data in this table employee violate referential integrity. Why is that? That is because I have not added, no, I have not added any spouse data, right? It's that. There may be records relating to the employee in the related table, but no record in the employee in the primary table. What is that? Okay, for the time being, I will say no. Why is that? Why not reference? Because I have not added any spouse record, right? So that is strange. Okay, for the time being, I will say not to enforce referential integrity and create. Anyway, it has not shown it like one-to-one yet. All right, let me close and go back and see what happens to the spouse table. No record, right? No record. Has it entered a record? No, right? That is a strange error. Anyway, I have 1, 2, 3, 4, but spouse table still I don't have any data. So anyway, let's close it and again go back and see whether we can enforce referential integrity again. Double click on the relationship, enforce, still we get there. Okay, so let's open spouse table again. Design view. Yes, no duplicate. Because I haven't got this error before. And that is why I'm also curious now. Only possibility is I have by mistake add a record. But no, right? No record. Okay, let's add a record and see. Let's say Nimali. Employee ID is let's say 2. Let's say we can save it. Now let's see whether we can do it. So I drag this and put it there, right? Correct. Employee ID, employee, spouse table, employee table. I don't think that even ChatGPT will figure out what is this error. But anyway, I'm pretty sure ChatGPT will not be able to understand this. Okay, this is too complicated. But I just put it into the ChatGPT. Okay. If ChatGPT can answer this kind of a question, ChatGPT is super. But I don't expect this kind of a supremacy yet. I'm not at all expecting, just I'm adding. Okay. It cannot enforce referential integrity due to violations, blah, blah, blah. There are records in the spouse table with employee ID values that do not. There's no such case in my case. Employee ID in the spouse table must have matching employee ID. No. You must ensure that all employee ID values in spouse exist in employee before. But all these things are not there. So I don't have any of these issues. Spouse is intentional. Intentional spouse. But I don't think that is just my spelling mistake for the table name. Anyway, this guy has identified what is the issue is, but I don't think that these recommendations are there. Okay. Anyway, I'll just for the time being, I will make it not enforce referential integrity. Okay, because this is a strange error. But anyway, I have created the relationship. But you can't see this 1-1 because I can't enforce the referential integrity. Okay. Okay. So no duplicate must be set to this employee ID. So then only it become 1-to-1. Then only it become 1-to-1. Otherwise, it become 1-to-many. Okay. So you need to set it. So I have set it to employee ID, right? Index, yes, no duplicate. But if I don't select this, it will be 1-to-many. And it will be 1-to-many. So therefore, I need to do this. Right? I need to do this. So this is still I can't figure it out why I'm getting this error. So usually this work, right? Maybe I will have some other databases. I can show that this work. Maybe some local issue, maybe after some updates or whatever. Okay. Right. So just forget about it and see. Maybe you in your databases have you make it possible when you create like this? Have you got this error? If you are doing parallel with me, just double check and let me know. Create an employee table, spouse table, and make sure spouse ID is unique, and then drag those two and see whether you can create the one-to-one relationship with enforced referential integrity. Because usually I can do this. Only today I got this error. Before this class, I have never got this error. Okay. So anyway, I managed to create it. Only thing is I can't enforce referential integrity. Okay.
How to drag these two
Sorry.
tables?
So,
How to drag those two tables?
how to drag? You go to
Yes.
database tools, relationships. So you can see the relationships here. You can just right click. Oh, there's a add selected tables. Sometimes if you have a different version, maybe you need to right click and say show tables. It will give you a pop-up. From there, you can drag and drop also. Even you can drag and drop like this. Okay. But don't drag the same table twice. Okay. Right. So maybe you don't get this error because I also never got this error. This is the first time I got this error. Okay.
So it will create relationships.
Sorry?
Then it will create relationships.
What do you mean by it will create? That means you tried it and managed to create a one-to-one relationship.
Yes.
So it shows 1 and 1 in both sides.
I didn't created that, but how to create it?
What do you know how to create it? So drag this field and drop it to the primary key field. Drag your
Okay.
foreign key field, click on it, don't release it, then drag it and release it only when you are in the other table's primary key field on top of that. So then only you release. So then pop-up window will be there.
Okay, sir.
Okay. So I'll do it again. I delete the relationship. I click here, drag it, don't release it. And now only I release it. It enforce preferential integrity and create. Now I get this error. So therefore I need to untick this. But anyway, pick it as 1-to-1. What I ask is, do you also get in this error? Any one of you? Because this is the first time I got this error. Okay. So anyway, that is how you create one-to-one relationships. Okay. One-to-one relationships. Maybe I will have a look at it. Why I am getting this particular error. Okay. In Access. Right. So what we have discussed how to create. Now we'll add some data. We'll add some data. So already I have few employees with employee 1, 2, 3, 4. So let's say my Nimali has employee ID 2 as her spouse. Say Kumari, employee ID say 3. Okay. I can save it. But say I have another employee. So sorry, not employee, spouse, Amali. But now I can't add 2 again. Then of course it is 1-to-many. That means employee 2 has 2 spouse, but we wanted to make it unique. So now it should give me error. You can see there's error because it's 1-to-1. Either, right? So then you need to go for some other ID like 4. So then because there's valid employee ID called 4. Okay. Right. So we discuss how to create one-to-one relationships, one-to-many relationship, binary. Right. So now we move on to many-to-many relationships. How to design. Okay. How to design. So when it comes to many-to-many relationships, there is no simple solution. So the only approach is, okay, so I forget about the second approach here, right? One-to-one. Right. So that second approach I am not going to implement, but I'm just going to show it. Okay. Right. So this is the first approach where we take the foreign key into one of the side, preferably to the weak side, and make it unique. And then create the foreign key, map this foreign field to the primary key. Okay. Right. So the second approach is you create the relationship between primary key to primary key. You don't introduce a new foreign key. Okay. You need to introduce a new foreign key. So therefore, now basically OS, you can say your foreign key is your primary key also. So therefore, this is my employee table. This is my spouse table. So if Rehana is the spouse of Ravi Fernando, so then Rehana's spouse ID primary key must be same as the primary key of the employee tables, the related employee. If Sumudu is the spouse of Lily or whatever, so that primary key must be like, then of course you can't go for auto number. So here now the primary key is not the auto number. Primary key you must manually enter, and that value must be the same primary key that you use in employee table. So that is the second approach. It also works. Okay. And again, because this is a primary key, now you can't add the same value twice. So that make sure it's 1-to-1. So both the approach work. Both the approaches work. So some people prefer the first approach, where you add a foreign key and make it unique. And some people just map it primary key. Okay. Right. So now let's move on to many-to-many binary relationships. So many-to-many means one instance of A is related with many instances of B, and one instance of B is related with many instances of A. So remember, when you model many-to-many relationships in analysis also, I told you there's a possibility of associative entity. That relationship itself can have attributes. Right? So that attribute neither belong to left entity nor right entity. So that possibility was there. Okay, like for example, employee can work for many projects. And one project can have many employees, many to many. And employee ID, employee name can be here. Project ID, project name can be here. But what about number of hours a particular employee has worked for a particular project? So we add it here, right? Because it is neither belong to this nor to the other one. And I told you later when designing, this become another table. And these attributes will become fields in that table. So if it is a many-to-many relationship, we always add a connecting table and map it as two one-to-many relationships. Okay. Two one-to-many relationships. Say student and course. Student can register for many courses. Obviously, one course can have many students. Okay. So then we need to introduce a connecting table like this. Say this is my student table. This is my course table. Because it's many to many, student can work, register for many courses, course can have many students. So then we need to introduce a connecting table. and build it as two one-to-many relationships, where the many side is the connecting table. Okay, because when you create a one-to-many relationship, many side has a foreign key. So therefore, this is your foreign key for this table. This is your foreign key for this table. And additional attributes we can edit also. And make sure this combination of two foreign keys is your primary key, or you can go for a surrogated key, auto-generated key. Okay, right. So let's do it as a practical thing in our database. So remember, we have employee. We have, let's say we have something called project. So let's add some attributes for the project. Say project ID. Let's say auto number, primary key. Say P name, short text, maybe project location. Okay. Primary key is project ID. Right. So now employee can work for many projects. Project can have many employees, many to many. Okay, let's add some project data also. Say project ID 1, I'll call it P1, next one P2, maybe next one P3. Now, project can have many employees. Employee can work for many projects. So what is the solution? Okay, let's add that to the database relationships. So this is my project. So this is my project. So employee can work for many projects. Project can have many employees. Now it's a many to many. So I'm going to introduce the connecting table and build it as two one-to-many relationships. Okay. Right. So let's create the connecting table. Table. You can give any name, but common convention is combine the two names. Say employee underscore project. So then anyone can easily see that this is a connecting table. Okay. It's convention, not a rule. Right. So let's have the employee ID. You can give any name, but I prefer to use the same name. Not auto number now. It's just a number because it must be a valid value in employee table. So then project ID. Let's go for number again. And now this combination must be your primary because employee can work for many projects. So now select this, click on shift, okay, shift key, then click the other one, don't release the shift, then right click and say primary key. Now you can see both combination is the primary, composite primary key. You can see the key symbol in both employee ID and project ID. And now if you want, you can add additional field like hours work. So let's make it number again. That is
So does
employee.
that,
Sorry?
sir, what is the key that we use? Control or shift?
Shift. So you select this and shift if they are next to each other. If they are not next to each other, you can even use control also. Both work. You can use it by the shift. Shift can be used when they are next to each other only. But control you can use at any time. Any combination can be used. But I think shift is the one that work mostly. Okay. No, I think any shift and control both work. But because if you shift it to separate places, then the middle one is also selected Okay, so if they are in the
Okay,
same
sir.
location, use shift. Otherwise, control. But always control work. Okay. Right. So now I have the connecting table. Uh, so now I remember you close your tables whenever you go to the database tools. Okay, close. Otherwise, you will get error. Right. So now I can add connecting table, employee project. And now I want to create the two one-to-many relationship because I have the two foreign keys. So drag your primary key, your foreign key to the primary key of the employee table and create it as enforced referential integrity. It's a one-to-many. Yes, now it is two one-to-many relationships. And project ID, drag and drop it to the project ID, enforced referential integrity. So now I have created that many-to-many as two one-to-many relationships. Okay, two one-to-many relationships. And I have added another attribute also, like hours worked. So that is how you model many-to-many relationships as two one-to-many relationships. And I have composite primary key also. Right, so let's add some data. See, I already have project 1, 2, 3. Already I have employees 1, 2, 3, 4. So therefore now I can add, say, employee 1 has worked 10 hours in project 2. Now the combination must be unique. So employee 1 has worked for project 3 15 hours. Say employee 2 has worked for project 1 30 hours. Say employee 2 has worked for project 3 5 hours. Say employee 4, so say employee 3 has worked for project 1 12 hours. Employee 3 has worked for project 2 6 hours. And employee 3 has worked for project 3 8 hours. Likewise. Okay. Right. So now I have a database with one-to-one relationship, one-to-many relationships, and many-to-many relationship model as designed as two one-to-many relationships. Any questions? If you have any questions, this is the best place to resolve it. Because whenever you develop a software, you need to think about database. Of course, if you are working with structured data. In your final year, you need to do this. A lot of students, they don't know how to design a database, unfortunately. So that means they have not done their semester 2 properly.
So what is mean by exactly one-to-one relationship?
So one-to-one means one instance of left table is related to one instance of right table. And one instance of right table is related to one instance of left table. That is called one-to-one. One spouse is related to one employee is related to one spouse. That is called one-to-one. Okay. Like one person, one ID. One ID is for one person. One country, one national anthem is for one country. One-to-one. Okay. Right. So now we have discussed about one-to-one, one-to-many, many-to-many, related to binary relationships. Now we can even generate some forms so that we can remember forms are end user tier. Now we are working with what? Middle tier, logical tier, not the physical tier or the user tier. So physical tier is actually finding the files. That is your access take care of. Right? Index files, data files. So we work with relations and relationships. Right? Relations and relationships. That is why we work with primary keys, foreign keys. But still my database doesn't have any user tier, external tier things. Because end users, they don't like to work with tables. They like to work with reports for output and forms for input. So in Access, we can very easily, even the Access can generate some forms. So select each and every table and say create form. Right? Close it so that you can give it a name. You can use the same name because it is saved as a form. Right? So then employee create form. Of course, you can customize this. Employee project form. You need to close it. Otherwise, you can't enter data. Right. So now I have a set of external or user tier objects also. So let's look at employee. Right. Employee one, Nimal, salary is this, department is two. And these are the projects that employee Nimal work for. Project 2, 10 hours. Project 3, 15 hours. So if you want to go to the next employee, you can go here. There's an arrow key. Right. Kamal, 120,000 salary. Department 1 is where Kamal work. And these are the project details. Right. And so on. So Raju has worked for 3 projects. These number of hours. Now we can see it makes sense, right? So once the database design is done, even tools can generate the UI for simple applications like that. Okay. So then what about the project? So project 1. So these are the number of hours worked by different employees for project 1. Employee 2 has worked for 30 hours. Employee 3 has worked for 12 hours. For project 2 and project 3. Project 3, there are 3 employees. Okay. So what about department? So you can see the HR department has only 1 employee. Come on. Finance department has Nimal and Rehana. Marketing department still no employees added. So it makes sense, right? Because end users prefer the third, fourth app, but we can generate this, so we can code this once you have a solid database design, right? With primary keys, foreign keys, and so on. Right? Any questions? Especially, you must be really comfortable with adding connecting tables to facilitate many-to-many relationships. Right. So now we'll look at unary relationships. So unary relationships are rare but possible. So therefore, you can't just survive with only binary relationship, knowing binary relationships, knowing how to design binary relationships. So there are situations, there are unary relationships. Okay. That is degree of 1. The relationship has degree 1. So unary relationship means a relationship between instances of the or records or tuples of the same table, same relation, same entity. So then it is unary. And that relationship can be one-to-one, one-to-many, or many-to-many. Okay. Right. So let's take one by one because you must be really sure about this. Really sure about this. Now, a lot of students want to go into data science, right? And blah, blah, blah. So how do you go to data science if you don't know how to model a unary relationship? So these are the prerequisites. Okay. Right. For that, I will be using different sort of tables. Okay. Because this, our database is now already fairly complicated. Right? Fairly complicated with so many tables. Okay. I will be using the same database, but I will model these as isolated things. Okay. Isolated things. Okay. Right. So let's create a one-to-many unary relationship. One-to-many unary relationship. Something like, say, employee can have one supervisor. Supervisor is also employee. Okay. Or sometimes we call it mentor and so on, who can guide you. But one supervisor can guide many employees. But one employee can have only one supervisor, one mentor. That means one-to-one unary because supervisor is also an employee. One-to-many. How to do that? Let's first create a, anyway, now employee table is already there, but then we get little bit more complications to this table, right? What can I do for that? Okay, so shall we create a different database?
Okay, sir.
Let me check what are the other tables we have. Student, yeah, person, yeah. So we'll go for a different database, okay? By the way, I will share this database with you. Remember, I have a small issue here that is between the employee and spouse, I cannot enforce referential integrity, okay? So that issue is there with this particular database, okay? But anyway, I will share this with you. Save as. The codes. I'm doing this a little bit slowly because this is serious stuff, okay? Designing. I'll call this database. Say multiplicity, binary relationships. I'll close this. I'll share this with you. Otherwise, I'll forget it. Fine. So by the way, no point looking at my database, right? You need to create it. I just gave it as a reference only. Right. So now let's create another database. New. Then I will save this also. I'll call this unary relationships. Right, unary relationships. Okay, that is it PowerPoint. Oh, it is a PowerPoint. Sorry for that. Okay, it should be database. Not PowerPoint. Access. 。 . 。  . 。 . . . . . . . . . . . . . . 。 . . 。 . . 。 . . 。 。 . 。 。 . 。 。 . . 。 。 . 。
Okay, sir.
Now it should work. Right. So let's create employee. Okay. I'm going to create a unary one-to-many supervisor relationship. Okay. Employee. And let's add some fields. Say employee ID, primary key, and e-name, employee name, and maybe salary. Just okay. Salary will make it number. Right. So now I need to create one-to-one relationship. An employee can have one supervisor. Supervisor is also an employee. And one supervisor can supervise many employees. One to many unary. So now remember we need to add the foreign key to the many side. But in this case, both one side and many side is the same table. So therefore you just need to add the foreign key to your table. But this time you can't use the same name because you can't have two fields with the same name as your primary key. So therefore give it a different name. Okay, so I'll call it supervisor ID. I'll do it practically because I can't give two fields with the same name. Supervisor ID. And let's make it I think I have added a special character. Okay, so that is fine. I will make it number because I'm going to map this to the employee ID of the same table. Now I can create the relationship. Okay. But in Access, there are some limitations. Okay. There are some limitations. Right. So I will add the employee table. Now in Access, I can't drag supervisor ID and put it back to the employee ID. That is not allowed. But that is what I want to do. That is why it's unary relationship. Okay. So that is what I have modeled here also. Right. Supervisor ID is mapped to the employee ID. But in Access, it doesn't allow drag your supervisor ID and put it into employee ID. So therefore, as a workaround, you need to take a copy of the same table again. It's just a copy. Okay. Copy. You can think of it something like this. Okay. Then you can drag supervisor ID and drop it to the employee ID in the copy. This is just a copy of the diagram, right? Not two tables. So now I can drag it and drop it in the employee ID and enforce referential integrity. And it will be considered as one-to-many relationship. So don't think that this is binary. This is also employee because Access doesn't allow me to create in this recursive way, right? So now I have created one-to-many recursive relationship. Now let's see whether we can add data also. Say employee ID 1, say Nimal, salary is 100,000, and maybe no supervisor. Maybe Nimal himself is supervisor. Say Kamal. I use this Nimal, Kamal, Namal because it's easy to type. Okay. Right. So 120,000. Maybe he is also supervisor. So therefore, no one is supervising Kamal. Let's assume. Okay. So let's delete this. Now let's say we have Bimal. Say salary is 80,000. Now I will say Bimal's supervisor is Kamal. So then I can say 2 because Kamal is employee ID 2. Say I have another one, Ravi. Salary is 70,000. I can say Ravi's supervisor is also Kamal. Right? Recursive one-to-one relationship. Say another one, Rehana. Says salary is 90,000. And maybe I can say supervisor is 1, Niman. So this is how you create unary one-to-many relationship. An employee can have only one supervisor, but supervisor can supervise many other employees. Supervisor employee can supervise many other employees. So it's a unary one-to-many relationship. Okay. So this is something like this. Okay. Only thing is because Access doesn't allow me to drag and drop, I had to get a copy and do it. But in reality, this should be the diagram. Right? This should be the diagram. One-to-many union relationship. So your foreign key is also in the same table, okay? And it is mapped to the primary key of the same table. Right? So that is unary one-to-many. Then you can have unary one-to-one. So you must always have practical examples for each of these scenarios. Okay. So unary one-to-one means one instance of a table can map into another instance of the same table, same relation, but not many. Another way also one-to-one. Okay. So then we call it unary one-to-one relationship. So this is a very typical example I usually take. A student is paired with another student, like when you go on a trip when you are in the primary schools, usually, so they pair it with another student, right? And those two supposed to stay together until they come back to the school. Pairing. So therefore, one student is paired with only one other student, not more than one. So therefore, it's one-to-one. And pairing is the relationship is two instances of the students. So it's a unary one-to-one relationship. Okay. Let's do that also in the same database, but those are isolated examples now. Okay. And so let's create student. Student. Go to the design view. Student ID. Auto number, primary key, and S name. Right. Let's say we need only those two. Now I need to create the unary one-to-one relationship. One student can relate to another one student. So therefore I need to insert foreign key field. I'll call it friend ID or partner ID. So let's say partner ID. And because we are going to map it to our primary key, let's make it number. Now I need to show that this is my foreign key. So for that, I will go for the database tools. Right, drag and drop student. Again, I can't just drag and drop partner ID to the student ID to the partner ID. Therefore, I need to take a copy of that. But now I am going to make partner ID unique. Otherwise, it will be again one-to-many. But again, I might get this same issue that I encountered. So in that case, I will not make it enforced referential integrity. Okay. Right. So let's go and do that first, because otherwise it will be one-to-many. Right. So partner ID, I'm going to make it index. I'll say yes, but no duplicate. Right. No duplicate allowed. So that is to make it one-to-one. Now I'll go to database tools and drag partner ID to this. And again, I might get the error. Okay. Enforced referential integrity one-to-one now. This one allowed. That is strange, right? Maybe earlier I had some data issue because this allowed even when it is recursive. Unal. Maybe some data issue with that previous one. Okay. right? So this is one-to-one unary. Of course, ideally it should be something like this, but due to the limitation in access modeling, I need to take the copy. Okay. Therefore, don't think this is binary. Let's add some data also. Say student Nimal, say still no partner. Okay, for the time being, I'll call one because it says mandatory. But anyway, usually we don't partner yourself, right? One student with the same student. And so let's say Nimali, say Nimali is partnered with Nimal. So then, of course, Nimal must be partnered with Nimali. Okay. So therefore, I call this one. And why can't I do that? Student indexes related report. What is that? Say one is related to two. Why I'm getting it? Okay, let's say one is related to one, two is related to two. The record cannot be deleted or changed because table student includes related records. What is mean by that? Okay, I'll say yes. Okay, now let's see. Okay, so now let's see whether we can do it. So this is to save. Record cannot be deleted or changed because table student index includes related records. What is that? I think this referential integrity is giving me some issues. I will again remove the referential integrity, okay, for the time being, because I think it's giving me some issues. Okay. When it is one-to-one, you can see one-to-one is giving me some issues. So I'll say no, don't enforce referential integrity. Now the one is not there. Still, I have make it one-to-one. Okay. Right. So now let's see whether I can do it now. Say Nimal's partner is Nimali. That is duplicate issue. I will delete it for the time being. Now I will make it one. And now I will make this two. Now it should work. Right? So now Nimal's partner is Nimali. Nimali's partner is Nimali. Okay. So let's have another student. Say Raju. Say Raju doesn't have partner yet. Let's say Rehana. Say Rehana's partner, I will make Raju. And Raju's partner, I will make Rehana. Now again, I can't add the same value twice because this is unique. Right? This is unique. Therefore, this is effectively one-to-one unary relationship. Okay. One-to-one unary relationship. This one. But this one-to-many. Because an employee can have many, supervisor can have many employees. So let's add, shall we generate the form? But anyway, the form may not be very useful, but I will anyway generate. I will select employee and say generate form. Right. So you can see the Nimal. It looks like Nimal doesn't have any, not supervising anyone, right? Let's go to the next one. Yeah, you can see this. Actually, there's an issue with this form also because when I say employee, if he is a supervisor, the employees who is supervised by that employee must be listed here. But for some other issue, it is not also listed. Okay, right? Don't worry about that because Access is not very sophisticated about union relationships. Okay, I will do it for student also, but anyway, it's also not going to may not work. At least you can see the partner ID here. The partner ID here. So therefore, Nimal's partner ID is 2, right? Nimali's partner is 1, and so on. Okay? Right. Anyway, don't take these forms seriously. Now we have unary one-to-one, unary one-to-many. The third one is unary many-to-many. Right? Unary many-to-many. So unary many-to-many means it's between two instances of the same table, but it can be many-to-many, like Facebook. A particular user can have many friends. Friends are also users. And that particular user can have many friends again. Right? So it's basically unary because users are there, Facebook users. Say X has, so let's say A has a friendship with B and C. And B has a friendship with D and E. And maybe C also has friendship with E and F. Now you can see that B can have many friends, and those friends also can have many friends. So many to many. Right? Many to many. So how do you model this? Because it's unary. So because it's many to many, now you need to introduce a connecting table. Okay. Right. So let's do how to do it. So this is my table, the person or user. So you need to introduce another connecting table like friendship or whatever, and build it as two one-to-many relationships. And your many side is the connecting table. So this is the hardest to understand, right? You must be very serious, right? If you really want to understand this. And this is a friendship. There's a friendship between 1 and 2, Shehan and Ravi. There's a friendship between 1 and 4. That is Shehan and Fatima. And there's a friendship between 2 and 1, Ravi and Shehan, and so on. And we can have some additional fields. The friendship start date. You can friendship request එක දාලා accept කරපු දවස. Maybe friendship type. ඔබ දන්න Facebook වල තියෙනවා නේද? Close friends, general friends, acquaintance, and so on. එතකොට close friends ලාගේ තමයි post වැඩියෙන් පේන්නේ. අනිත් friends ලාගේ එහෙම ලොකුවට පේන්නේ නැහැ. So those must be related to this connecting table because same person can have different friendship start date for different friends. Therefore, those associative attributes must come into this connecting table. And this table is connected to the same table twice. So therefore, we need to give it a different name also because you can't call it person ID. Like person 1 ID, person 2 ID, or friend 1, friend 2. Okay. So think about it. So this is the most complicated situation, but we can do it. Right. So let's do it. Okay, I have I will create a table. I'll call it user. Okay, user rather than person. User, like Facebook there. Okay. So let's say user has user ID, auto number, primary key, then uname. Right? Maybe that's enough. Now I need to have that connecting table because this is many-to-many many-to-many unit relationship. So let's create let's add some users. Say Nimal, Amal, Kamal, Ravi. Now there can be some friendship between these guys, okay? Now I will create the connecting table because we are going to map it as to one-to-many relationships. These associations, recursive association. So let's call it, I'll call it friendship. Or I can call it user underscore user if you go by our convention, right? Connecting table is given the name of the two tables, but in our case, it is both the tables are the same table, user. Therefore, if you want, you can call it user underscore user also. Okay, I'll just call it friendship. Now I need user ID twice, right? So therefore, I'll go for the design view. Say I will call it user one ID or user ID one or whatever, right? User one ID, not auto number, just a number. So this is serious stuff, right? Say user two ID. මේවා තේරුම් නැති වුණාම ෆයිනල් ඉයර් කියලා ප්‍රොජෙක්ට් එක කරන්නම් බෑ. උපාධියක් කොහෙන් හරි ගත්තත් ඉන්ටර්විව් එකට යන්න ආත්ම ශක්තියක් නැහැ. හරි. වැඩක් කරගන්න බෑ. මේවා කවදා හරි ගෙනගෙන තමයි ඒවට බහින්න වෙන්නේ. Right. I will say date or type of friendship. Say friendship type. Let's say simple short text. Now I want to make user one and user two together as the primary key. So therefore I will use shift or control and then say primary key. So this combination must be unique now. So there can't be two friendship amongst the same two users. Okay. Now we can add some data to this one also. Before that, let's create the relationship, right? Database tools. I'll get the user. I'll get the user again because no. Yeah, I need to get the user again because I can't create the two relationship with the same table. Actually, these two are the same, okay? Then I'll take the friendship connecting table. Now I can create the two one-to-many relationship. User one ID, drag it to the user ID. Right? Enforce referential integrity. Why can't I do that? Right. And this one, drag it to the user two ID. Enforce referential integrity. Now I have the two one-to-many relationship. So that effectively create a many-to-many relationship between user and user. Here is also user table, okay? Because access doesn't allow me to create two relationships. That is why I need to take a copy. You can always think that this is same as here, okay? So it's something like this, okay? Right, so now I have created the connecting table for many-to-many, unary many-to-many. And I'll close it. Right, so let's add some data. Already I have user, say friendship. Say there's a friendship between user one and user two. Say friendship type is maybe close. Say there's a friendship between 1 and 3, which is normal. Or you can give some flags or whatever, okay? So there's a relationship between 2 and 3, maybe which is close. Maybe there's a relationship between, I have only 1, 2, 3, right? Yes, we have fourth user. Say there's a relationship between 2 and 4, maybe that is also close. Now you can see there can be multiple friendships. One user can have multiple friends, and that friend can have again multiple friends. Right? So all are users. So this is how actually the Facebook works. Okay, Facebook works. Right. Any questions? Because we are done with unary relationships. So we have done with unary one-to-many, unary one-to-one, and unary many-to-many with connecting table. Actually, you need to think like this, okay? Here also you need to think like this, and there's a relationship between the same, okay? Here also you need to think like that. That is because access has some limitation. Right. Any questions? Any questions about unary relationships? Again, whether it's binary, unary, ternary is different, independent from whether it's one-to-one, one-to-many, many-to-many. So therefore, any combination can be there. Okay. Right. So now we can move on to our third one, ternary. Right. Ternary. Oh, I have forgotten the ternary one. Right. I have forgotten to add the ternary example. I will add it. Okay. I have forgotten to add the ternary example here. Uh, right. So let's add a ternary relationship. I'll do it practically. I'll take the same example we discussed during analysis. Okay. Uh, so this is my unary relationships. Okay. For ternary, I will create a different database. Okay. Different database. So this is my binary, sorry, unary. I'll share this also. Right. I'll create another database now. I'll call it ternary relationship. Okay. So make sure you keep your files. Okay, files සමාන නැත්නම් මැකෙනවා ටික දවසක් ගියාම. Right. So we'll take the same example. Product, right? Maybe brand, location, product. Okay. So that is say Cecil fan. How many items are in Colombo? Okay. LG fans. How many items are in Colombo? Maybe Cecil gas cookers. How many items are in Candy? Cecil gas cookers. How many items are in Jaffna store? So it's a ternary relationship because we need this brand, this product, this location, how many items are there? Okay. I gave you some other examples also, right? Buyer, seller, and the broker. So this buyer, this seller with this broker. There's a contract. Okay. Okay, so shall we go for the buyer, seller, and contract then? Buyer, seller, contract. But buyer and seller has pretty much the same attribute. So therefore, let's go for this one. Brand, item, location. Okay. Right. So let's create table. Let's call this location or store. Design view. Say store ID. Let's make it auto number and maybe location. Text. Right. So we can add some data also. Say Colombo, Jaffna, and maybe Candy. Right. So those are the stores. Now I will add brands. Brand. say ID or brand ID, and brand name or B name, short text. Let's add some data. Say Cecil, LG, maybe something like Samsung. Right. So now I will add the third table, product. Product to item. So let's go to the design view. Say product ID. That's our primary key or tow number. And P name, product name. Okay. Right. So let's add some data for that also. Say product name, fan. Product name, iron. Product name, rice cooker. So forget about different type of rice cookers and so on. Okay. Just assume we have only one rice type of item for rice cookers. Right. So now I have the three things, but these things are now related. That means we need to track how many Cecil fans are in Candy branch. How many Samsung, say, fans or rice cookers in Colombo branch. So it's a ternary relationship. Okay, so ternary is always usually one many to many. Don't worry, anyway, we are going to add a connecting table. Okay, so let's add the connecting table. Right. So again, you can give any name, maybe store underscore product underscore brand or whatever. Okay, so I'll call it like that. Say product underscore brand underscore location, or you can give just normal name. Now you are going to have the three foreign keys because we are going to have three relationships with this one, three one-to-many relationships. What are those? Brand ID. Let's start with product ID. You can give any name, right? It must be number. Then brand ID, number, then store ID, number. And this combination of these three must be your primary key. Now it's a three-field composite primary key. Primary. Let's set something like quantity. That means from this brand, this product, this location, how many items are there? Quantity. Let's make it numbers. Okay. Now we are done. Okay. Now let's create the relationships. Brand is there, product is there, store is there, and this is our connecting table. So brand ID, this is my foreign key. I'll take it to the brand ID table and release. Enforce referential integrity. Product ID. I made a mistake. So this is product ID, right? So I'll delete this. So product ID must go into the product table. So product ID into the product table. Enforce referential integrity. Brand ID into the brand table. Enforce referential integrity. Store ID into the store table. Enforce referential integrity. Okay. This is how we design relationship, a ternary relationship. There's a ternary relationship between brand, store, and product. And this is the quantity from this product, this brand, this store, how many items are there. If a table is a weak entity built from primary keys from three tables, then their relationship between the three tables is called ternary. No, there's no weak entity here. So these are normal entities: brand, store, product. So there are three entities, and there's a relationship between three entities. Okay. So there can be relationship between three entities, right? තුන් දෙනෙක් අතර relationship එකක් ඇති වෙන්න පුළුවන්. නමුත් ඉස්ම relationship ඇති වෙන්නේ දෙන්නෙක් අතරම කියලා ගන්න නැහැ. තුන් දෙනා අතර එක relationship එකක් හැදෙන්න වෙනවා. හරි? තුන් දෙනා අතර එක relationship එකක්. මේ ඇවිල්ලා දෙන්න අතර relationship තුනක් හැදෙනව නෙමෙයි. හරි? මෙහෙම එක relationship එකක්, මෙහෙම එකක්, මෙහෙම එකක්. මේ තුන් දෙනා අතර එක relationship එකක් හැදෙලා තියෙනවා. So therefore this is a different story. Okay? This is a different story. Right. So now we have the connecting table also. Now we can add some data and see also, because now individually we have data. We have the brand, set of brands, set of products, set of stores. Now I can say, so product one from brand one in store one, say we have 10 items. Cecil fans in Colombo, there are 10 items. So there are 10 items of Cecil fans in Colombo store. So maybe fans, Cecil, maybe Jaffna or Candy. So we have 20. Okay, so maybe some other product from the same Cecil brand in the same Colombo branch, 5. Maybe 2, 20. So likewise, now this combination of these three must be unique. Again, I can't have something like 2, 1, 1. But I can have 2, 1, 2 or 2, 1, 3. 2, 1, 3. Maybe 40. No issues. So this is a ternary relationship. Any questions? Any questions?
So what is the difference between the two, ternary and unary?
Ternary and?
Unary.
So unary means relationship is between the two instances of the same type, same entity. Ternary means relationship is between instances of the three different types. So that is what ternary.
Okay, sir.
Okay. Two different types, two different entities. The relationship is between two different entities. So this one, the relationship is between three different entities, but one relationship. One relationship. Right. So that is a ternary relationship. So you can even go for 4 entities. So then connecting table has 4 foreign keys. Okay, 4 foreign keys. So let me put this also ternary. So unit, binary, unary, ternary, all three are given. Okay. Right. So I will add the ternary examples to this one. Okay. I have forgotten to add it to your slides, the ternary one. Okay. I think the ternary one was in the analysis, but not in the design. Okay. For some reason, maybe I have deleted the page or whatever. Okay. I'll add it. Right. So now we'll move on to a few more concepts. Now we are almost done. Remember, this is the most important thing. This is the most important session in your design, database subject. So the මෙතන තේරුම් නැත්නම් ඔතනින් එහාට මුකුත් කරන්න SQL query වලට නැහැ table database එක design කරගන්න බැහැ නේද? වෙන දේවල් කරන්න බෑ database එක design කරගන්න බැහැ. database එක design කරගන්න බැහැ නම් software එක එතනින්ම හිර වෙනවා. එතනින් එහාට ඉස්සරහට යන්න බෑ වඩ. ගොඩක් අයගේ database එක තනිකර mess කරලා තියෙනවා. mess up. එතකොට ඔයාලට අර කියන functionalities implement කරන්න බෑ. business tools. ඒතකොට ටෙස්ට් කරනකොට අහු වෙනවා පිස්සු නටනවා දැන් database එක. database එකේ ඒ කියන situations වෙන්නේ නැහැ. restrict වෙන්නේ නැහැ. එක විකාරයක් බවට පත් වෙනවා. මේ database design එක ඇතුලේ සෙල්ලම් ගන්න බෑ. ඒ කියන්නේ කිසි සැකයක් තියෙන්න බෑ. සැක නැති වෙනකම් එක එක පොඩි examples කර කර design කර කර ඒවා double check කර කර කායෙන් හරි අහලා මේක හරිද? එවන්න පුළුවන් ආවකට database design එකක් කරලා මට එවන්න. හරි access වලින් හදලා මේක හරිද? මේක වැරද්දක් තියෙනවා. අපි හදලා එවන්න හැබැයි නිකන් ඔය රූප ඇඳලා එවන්න එපා. database එකත් හදලා එතකොට මටත් පුළුවන් වාගේ ER එක බලන්න design tools වලට ගිහිල්ලා. So then I can say these are improvements you should do. This is in you have not done it in a very way. Okay. Right. So now we'll move on to some other concepts in when we do designing, we need to consider constraints. Right. So the constraints we have already done, but now we are going to look at it in a very formal way, right? With some standard terminology. So constraint means what? Restriction. Constraint क्या है? Restriction है. So why do you add restrictions? Maybe we want to preserve some integrity, validity. නේ ඕගොල්ලෝ දෙක සමහර පාරේ යනකොට බම්පර් දාලා තියෙනවා. ඒක constraint එකක්. ඒ ආරක්ෂාවට. අපිට constraint කරන මේ values විතරයි දාන්න පුළුවන්. අනිත් values දාන්න බෑ form එකේ. check box එකක් දාලා කියන මේ තුනෙන් එකක් select කරගන්න. So those are constraints. So these constraints can help preserve the integrity and validity of our data. Otherwise, there will be some invalid scenarios in your database. So we will look at three constraints: entity integrity constraint, referential integrity constraint, and other field level constraints. Okay, this is one classification, the most widely used classification. Let's take one by one. So entity integrity constraint, we already, this is actually, you don't need to enforce it. When you select a primary key, this constraint is already implemented by your database. So entity integrity constraint says, for each record, your primary key value must be unique and it cannot have null. So if a particular field is your primary key, for that you can't have the same value twice. And also you can't have null values. You may have null values for other fields, but not for the primary key. And you can't have the same value twice. So primary key must be unique and not null. Primary value key must be unique and not null. So by default, when you select something as a primary key, it's unique. It's enforced by your database. And it doesn't allow you to have null values also. But when you create a table in SQL, you need to say that it is a not null field. Okay. Not null field. Got it? Now I close the wrong file. If I open my database, this one, and say employee, I cannot insert employee with null employee ID. Of course, in this case, I can't demonstrate this because it's auto number. So therefore, it will add that value. So that means I am not supposed to save an employee record with employee ID is null or empty. In this case, anyway, I can't do it anyway because it's auto number. මම කොච්චර empty තිබ්බත් එයා නම්බරයක් දාගන්න. හැබැයි auto number නොතිබුණ වෙලාවක ඔයාලට එකක් එන්න ඕන enter කරේ නැත්නම් නම්බරයක්. And that number must be unique. That is called entity integrity constraint. Okay, entity integrity constraint. So then referential integrity constraint. මම හැමතිස්සෙම ටික් කරන්නේ relationship එකක් අතර තැන් වල එකක error එකක් ඇවිල්ලා මම untick කරලා යන්න ඕනේ. 1 to 1 නේවයි. So referential integrity constraint. So So the referential integrity constraint says your foreign key value must be a valid value in the referencing table, or it can be null. Primary key can't be null, but foreign key can be null. But if you add the value, it must be a valid value. But own නැති values දාන්න දෙන්නේ නැහැ. That is called referential integrity constraint. Okay. Just give 1 minute. Right. So referential integrity constraint says your foreign key value must be either valid value or it can be null. Okay. Primary or entity integrity constraint says your primary key value must be not null and unique. Okay, right. So then you can have any other domain constraints. Any other domain constraints. So domain constraint means constraints, restrictions coming from your business rules. Okay, or your domain. Domain can be business area, functional area. Maybe you can say marks must be between 0 to 100. Domain constraint. Maybe there's a business rule saying discount cannot be more than 50%. Then it's a domain business. From business rules, you restrict. Okay, domain constraints. So that is why you have these additional properties, restrict values and so on. And these are other field level constraints. So for other fields also, you can have unique constraints. Maybe it is not primary key, but still you want to make it unique. Remember we did that when we create one-to-one relationship also. That means it is not your primary key field, but you want to make sure that it is unique. Maybe your primary key is employee ID, but you want to make sure that email address must also be unique. No two employees can have the same email address. So then in email address field, we can say it's a unique field. And null constraint says whether null is allowed or not. For some fields, we will say, okay, null is allowed. Of course, primary key always not null. But some other fields also we can say not null. Though it is not the primary key, we don't accept null values. So that is called null constraint. Okay, unique constraint, null constraint. And there can be some other constraints also, okay, some other business constraints. Right, so now finally we move on to mapping inheritance. So remember, relational databases are not object-oriented databases, but relational databases also support certain object-oriented concepts, especially in modern databases. But actually, you don't need a specific support from database. Actually, we cleverly use the concept of relationships to somehow manage inheritance. And remember, in last time when we discussed databases, I explained when we have inheritance, there are two concepts: overlapping versus disjoint. Other concept is total versus partial. Now you must have understood those things, right? ඒවම දැන් I explain කරන්න බෑ. ඒවා එදා කරේ. ඒවා එදා. අද ඒවා අද. So now let's see how to design, thinking about whether it's overlapping or disjoint, total or partial. How do you map the inheritance in database tables? Okay. Yes, you need to create many-to-many relationships and also ternary relationship. You need to create a connecting table. Yes. So if a table is a weak entity built from PKs from 3 tables, then their relationship between 3 tables called as ternary. Here weak entities, product, and no, this is not a weak entity. This is a connecting table. Okay, this product, brand, location is not a weak entity. It's a connecting table. Connecting table is not a weak entity. It's a different concept. Okay, that is the answer for the other question. Okay. Right. So when it comes to mapping inheritance, you need to think about the possibility of total versus partial, the possibility of disjoint versus overlapping. Okay. Right? Keep that in mind. Let's see what are the possible ways of mapping. So there are few options, right? Few options, but you need to figure it out which option is going to work in which kind of a scenario. Sometimes you have more than one way to do it, but you need to justify why do you use this approach. Okay, right. So this is one approach. So this is your requirement. You have employee table, then every employee is either secretary, technician, or engineer. So it's disjoint. That means an employee can't be both a secretary and technician, or technician and engineer. It's disjoint. Okay. And also it is partial. So that means there can be employees. Now, an employee is neither secretary, nor technician, nor engineer. So in that kind of a situation, you can go for single table. Or single table will work for this kind of situations. Okay. So then you have all the fields, general fields, like employee name, salary, and all the special fields for each and every specialization, like typing speed, that is related to secretary. Technical grade, if you are a technician. Engineering type, if you are engineer. But it will be only one category, or none of the category. That is general employee. So then this will work. Actually, this work. For example, if that employee is a normal employee, none of these. So then you have the SSN, first name, say, I don't know what is it, min intis, maybe middle initials, last name, birth date, those are all coming from here. Address they have not broken into part, that is fine. So then maybe job type is null because it's not a special job title, or maybe just general. Then these values will be null. These values will be null because this is a normal employee. Say that employee is a secretary, so then these data will be there. Okay. And the job type will be secretary, and then this field will have the data. Okay. And if that employee is an engineer, so these data will be there. Job type will be engineer, and this field have value, this will be null. So you can see whether it's engineer or technician or secretary or none of these guys, it works. So job type will have either secretary, engineer, technician, or maybe none. Okay, none. So this is one possible approach. Okay, one possible approach. It definitely works when it is disjoint because your job type must have only one value. If it is overlapping, so having job type field is not going to work because then job type can be more than one. Overlapping means more than one. So then this field is not going to work. Okay, this field is not going to work. So therefore, you need to understand when you have a solution, what are the limitations of that solution. So here it works for partial and total, right? But not for overlapping. Not for overlapping. Because if you have overlapping, no point having job type because then job type is going to have more than one value. Okay, so that is how you look at it. Okay. ඔයා බලන්නේ solution එක දිහා බලලා මේ solution එක දාන්න පුළුවන් තැන් මොනවද දාන්න බැරි තැන් මොනවද දාන්න බැරි තැන තමයි overlapping. Overlapping. Right. We don't care whether it's total or partial. Right. And it works for disjoint but not for overlapping because we have a field called job type. Okay. So job type can't have more than one value. Right. Second possibility. Right. Hierarchy of multiple tables, one table for the super type and table for each and every subtype. So then you have the employee table, secretary table, technician table, engineer table. Okay. දැන් බලන්න ඕනේ මේ solution එක මොන වගේ situation වලට හරියනවද හරියන්නේ නැත්නම් මොනවාද. And the general fields are here plus job type field. So each specific table has again the same primary key and the special field. දැන් මේ කොයි වෙලාවකට හරියන්නේ. Again this doesn't work for මෙතන පොඩි වැරද්දක් කරලා තියෙනවා. overlapping වලට හරියන්නේ නැහැ. Why? There's a job type. Job type එකට එකකට වැඩි දාන්න බෑ. So this again work for disjoint because job type can be only one. Right? Job type can be only one. As long as you have the job type field, right? මගේ අතේ එක වරද්දලා ලියලා තියෙන්නේ. So can work only for disjoint. But it doesn't matter whether overlapping or not. Okay. Can be disjoint. Or work for disjoint. Work for disjoint. Only, right? Not overlapping. ඒක තමයි වැදගත්ම දේ. හරි. ඔය job type කියන එක තියෙනවද දැක්ක ගමන් ආදර ගන්න ඕන. එකට multiple දාන්න බෑ. ඒක disjoint වෙනවා. Only. හැබැයි we don't care whether it's total or partial. මේ හේතුව කියලා තියෙන්නේ. හරි. overlapping do not use type attributes in the super type. Okay. ඒ ඇවිල්ලා general tech කෙනෙක් නා. Partial. If it is partial then maybe you can keep this blank or you have a job type for general. Okay. මම මේක කොහොමද අප්ඩේට් කරලා ආයි දාන්න. හරි. Ternary relationship with unit name. Right. So the third possibility is single table with multiple type attributes. Single table එකට නම් අපි දැන් type attributes එකක් නෙමෙයි multiple තියෙනවා. Okay. So here you can see purchase flag as well as manufacturing flag. මේ flag දෙකක් තියෙනවා දැන්. මේ දෙකටම වලට වෙන වෙනම data දාන්න values දාන්න පුළුවන්. So because you have both the flags, now it can be overlapping. Because if it is overlapping, this is also true, this is also true. And you have these fields as well as these fields. So therefore now it works for overlapping. Right? If it is disjoint, that is also fine. එතකොට එක flag එක true අනිත් එක false. එන්න මේක disjoint වලට වැඩ කරනවා, overlapping වලට වැඩ කරනවා. flag එකක් තිබුණොත් එimhe overlapping වලට වැඩ කරන්නේ. flag multiple තියෙනකොට overlapping වලට වැඩ කරනවා. And of course it can be partial because මෙතන විතරක් part එක තියෙනවා පුළුවන් දැන්. හැබැයි මෙතන මේක example එකේ විදියට නම් මේක partial නෑ total. හරි total. Total වලටත් වැඩ කරනවා මේක partial වලටත් වැඩ කරනවා. Partial නම් මේ flag දෙකම empty වෙනවා. එතකොට අර additional fields වල data නැහැ. Okay? That is another possibility. Another possibility. So this is another possibility. So in this possibility, you don't have a table for this general fields, but you have table for these special cases. But these special tables have general fields also. For that, when a vehicle ID price වගේ මෙතනක් තියෙනවා. Price, license number වගේ. මේකෙත් තියෙනවා. So therefore, no general table, but you have two special tables only. Then මෙතන තියෙන restriction එවද්ද? So this work for disjoint and overlapping, right? But this doesn't work for partial. මේක partial ඒවට වැඩ කරන්නේ ඇයි ඒ? So if you have a vehicle which is neither car nor truck, ඉතින් ඒකට car එකට දාලා හරියන්නේ නැහැ, truck එකට දාලා හරියන්නේ නැහැ. ඒකට car එකට දාන්නත් බැහැ, truck එකට දාන්නත් බැහැ. ඒකට අන්නේ වගේ record එකක් දැන් දාගන්න තැනක් නැති වෙනවා. So therefore this work only for total, not for partial. But it works for overlapping and disjoint. By ගොඩක් අය මේක පාවිච්චි කරන අපි disjoint වලට. Preferred for disjoint. Only work for total. ඔක වැඩ කරන total වලට විතරයි. මොකද partial එකක් ආවා කියන්නේ ඒක vehicle එකක්, car උත් නෙමෙයි, truck උත් නෙමෙයි. ඒක car උත් නෙමෙයි, truck උත් නෙමෙයි එකක් දාන්න තැන නැහැ නේද? So likewise you need to understand the features of these possible designs. මේ එක එක design වල තියෙන ප්‍රශ්න මොනවාද? facility මොනවාද කියලා තේරුම් ගන්න. So දැන් ගොඩක් අපිට හම්බුණා නේද? So you go for 3 tables, you go for only 2 tables, you go for only the 1 table, and so on. So since there are multiple valid ways to design a specialization of entities, we must consider integrity and other performance aspects and select the most suitable approach. So maybe you have more than one way to do it. So it's your task as a designer to decide what is your best approach. Okay, done. Okay, it's a long session. It's a long session. I wanted to do it in single day because otherwise it's waste of time. Okay. අනිත් topic කොච්චර වෙලා යන්නේ SQL වලට එලා යන SQL කොහොමද දවස් එකක් යනවා. Right. So any questions?